In the last lecture, we looked at correlation. Now let's look at regression. A quick recap. Regression tells us dependency, which is cause and effect, how one value impacts the other. It can even be multiple values impacting another value. And the data is represented by a line. So correlation, remember, can be positive or negative. Correlation is when the values increase together, which is positive, and when they decrease, when the other increases, it is negative. We have perfect, positive, perfect, negative, then we have low and high, and then we have a zero correlation. Zero basically tells us that there is really no pattern in the data set. Like sometimes the value increases, sometimes the other value decreases, and the value does not have a pattern. For example, sometimes when I increase the sales amount, my profit increases. Sometimes when I increase the sales amount, my profit decreases. So remember, zero correlation also has significance because it means that there is an absence of correlation in your data. So especially if you're spending money on, let's say, advertising or marketing, and you see that there is a zero correlation, that probably signifies that your advertising does not really have a correlation with the sales amount, and you should reconsider advertising. I have given all the points in the PowerPoint, so if you want to, you can have a look at that. And just the one other thing before we come to regression, there is also something that we refer to as spurious correlation, which means that data might seem to be correlated to each other, but it is actually not correlated. For example, we see that when more iPhones were sold between 2007 to 2010, the iPhone was launched in 2007, the number of deaths caused by falling down stairs also increased. And these seem to be extremely highly positively correlated. But that doesn't make any sense, right? Because why would more iPhones mean that people are falling downstairs? So you have to be very careful because sometimes we are looking for answers when there are none. And especially in the pursuit to give a nice package to the client where we want to say that something is highly correlated and we should take an action, or maybe something is inversely correlated, we should be very careful before we present that number because it might be very, very misleading. Like I, from my experience, have seen a lot of cases where organizations have decided to reduce training expenditure because they see that that does not have a significant impact on performance, but that turns out to be a bad idea. So negative or positive correlation should always be taken with a pinch of salt, and there should always be some supplementary research to understand how important is that correlation to you and also whether you should trust it or not. Excellent. With that out of the way, let's come to regression. Regression has dependent and independent variables. Dependent is the criterion, which is what we are trying to understand and predict. For example, the sales value. And independent is the explanatory variable, which are the predictors that might influence the dependent variable. It's not necessary, but it might. And remember, you can only have one dependent variable, but multiple independent variables. Also keep in mind that when you search for regression equation, sometimes you will see this error terms. Now, Excel takes care of this automatically, so you do not really need to bother with it, but do not be surprised when you see this error term. So when you say regression error term, you will see that it's a random variable with a mean of 0 and a constant variance, right? I will not get into details here, but if you're curious about it, you can always go ahead and do this. In Excel, you will not find it because it is computed automatically. Wonderful. Let's start with the example. And we have a nice data set here where we are looking at advertising expenditure and the sales value. All right. Now, obviously, we want to find whether if we increase the advertising expenditure, which is measured in, let us say, lakhs, will it impact my sales, which is measured in crores? So if I increase my advertising expenditure to 0.82 crores, which is 82 lakhs, my sales is 15 crores. And when I increase it to 92.5, we get 25 crores, which I would expect. How do we find regression? Let's come to data and then data analysis. We select regression. We have the Y and the X range. In the Y range, we have sales, which we are trying to predict. We have the X range, which is the independent variable. We have the label in the third row, so we'll select that. We are not messing around with the constant and the confidence level. Let's keep the output range next to this in E4, and we want to see the residuals, and I'm not selecting the others. If you want to, these are certain plots. If you want to, you can make them later. And in one click, we get a lot of results. Let's go through them. Multiple R is nothing but correlation. As you can see, 0.9634, nothing but the correlation. Remember, I told you that when regression is calculated, correlation is calculated by default. We have the R square, which is a very important number, and the R square is typically read as a percentage, and the adjusted R square is also a percentage. If I quickly take you online and I say R square, you will see that it simply tells you the proportion of the variance that is explained in a model, which means what I'm trying to say here is that yes, there is a variance in my sales value month by month, and 93% of that variance can be accounted for by the advertising expenditure, while the other 7% of the variance in the sales value is due to other factors. And adjusted R square essentially tells you when there are a number of predictors in the model. So remember, it means that right now we only have one independent variable, but if we did have multiple independent variables, we would be using the adjusted R square. What it says is that if the new term improves the model and it decreases when a predictor improves the model by less than the expected by chance. Again, we're not getting into details here. This is not a statistics course, it's an Excel course, but if you want to read about it, you can just Google it and just pick up any good website to understand it. Right. We are not looking at the standard error here, but once again, this is available on the internet. Standard error in the regression is simply telling us the average distance that the observed values fall from the regression line, which we'll create in the next example. So it tells us how wrong the regression model is on average using the units of the response variable. I would suggest not focusing too much on it unless you really need to, because we don't usually present it in our corporate analysis, but sure, I mean, if you want to, you can Google it. Then we have the degrees of freedom. We have the sum of squares, the mean square, and the F value and the significance. You might want to look at the significance value here, since here you want to make sure that this value is less than 0.05. And the sum of squares is just like we had done in the first example, the standard deviation. Mean of square is sum of square divided by degree of freedom. So 3006 divided by 1, 232 divided by 22. And then we have F, which is nothing but 3006 divided by 10. Then these two numbers are super important. If I can highlight everything for you, I would say these five are what we need. Correlation, which is between -1 to +1. After that, we have significance, which should be less than 0.05, which is our analysis of variance. And then we have the intercept and our independent coefficient, which will essentially help us create the equation. All right, let's try to create the trend line. And then I'll explain how the residual output is coming. This is very simple. Insert a scatter chart like we did earlier. And then you go to chart element, trend line, and then select more trend line options. In the pane that opens on the right side, you want to select linear, and then you want to select display equation on the chart, display R squared on the chart, and also choose the forecast, which is, let's say, for another year, so 12 months. As you can see very nicely, or in fact, let's make it 24 months. So we can see the forecast for the next years like this. And since the least value that we have here is 82, I'm also going to select my x-axis and keep the minimum as 75 so that it looks a lot better. Wonderful. If you look at these numbers, this R square is what we calculated here, 92%, and also y equal to 0.4416x minus 18.029 is nothing but these two numbers, which are the coefficient. And how do these numbers help us, and how is this line getting extended? We can plug in these values, which means for next January, what do I expect that the sales would be? If we say that the advertising expenditure is going to be 109, for example, we can simply say equal to 0.4416 multiplied by 109 minus 18.029, and that gives us 30 crores. So it tells us that in January, if I increase my advertising expenditure to 109, I would expect 30 crores as the total sales amount, like this. And now if you go back, you can see the residual output is essentially calculating the predicted sales using the same equation for the 24 months of data that we already have with us. What that means is, if you look at the first two numbers, it says 82. I'm sorry, 15, if I say equal to 0.4415 multiplied by 82 minus 18, what it does is it gives me, sorry, it gives me 18.18, which is here. And the 3.18 is nothing but the residual, that is the difference between my actual sales and my predicted sales. Now do keep in mind that there would be a residual, which is okay, because a model can never really accurately predict because it's not possible to have all the dots on the line. That means that this line of best fit is trying to find a line that is as close to all these dots as possible, but obviously it is not possible for all the dots to be exactly on the line. That's the reason these residuals are there. Excellent. Just to wrap up this example, sometimes if you simply want to calculate the values independently, what you can do is you can write equal to linest, which is linear estimation, right? So using the least square methods to find a straight line. So we write linest, which is a linear trend. And all you have to do here is select sales and advertising expenditure, and we get two values. The numbers are not the same as this because the values are not the same. Let me just copy paste that. So we get the same number what we got earlier. We don't really have to run the regression in the analysis tool pack, neither do we have to create a chart. We can simply get the equation like this. If you only want the y-intercept, you can write intercept, which is intercept, and we select sales and add x. And if you only want the slope, we write equal to slope. That gives us the same number, which is 0.44. And of course, we already know the correlation coefficient, which would be simply a correl. And why is this not working? I'm sorry, just a moment. Okay, 0.96. Excellent. So you can either run the regression on the analysis toolpack to get the coefficient. You can create a line chart and show the equation, or if you just want the numbers, you can simply run linest, intercept, and slope. We have learned how regression works, and of course, I'm sure you can all think of different ways in which this can help you. So make sure to practice this and even try this with examples where you have multiple independent variables, where the only difference is that you will get some additional coefficient values, only one intercept, but additional coefficient values. In the next lecture, we will look at forecasting.